Hi folks, this is Calc 3, Quiz 13. We're given a double iterated integral. In part A, we're asked to sketch the region in the xy plane over which this integral is being evaluated. So let's go ahead and get our axes here. X and Y. We'll look from the outside in. The last integral we perform is an integral on y. The y is being chopped up from a constant -2 to a constant 2. So that's the interval we're chopping up on the y-axis. Now we look for a fixed y. What's the x run between? Well, it runs from x equals y squared to x equals 4. So you think back to college algebra, or in Calc 2 we talked about the conics. Either way, x equals y squared is a sideways parabola. It's going to have a vertex at 0, 0 and going to open to the right. When y is -2 and when y is 2, x is going to be 4, which ties together then the other boundary of the region. And so here's the region R. In part B, we're asked to write an equivalent integral with the integration order now dy dx. Okay, so I need to go in and chop up the x's. I chop the x's up from a constant 0 to a constant 4. And now for a fixed x, I have to determine what the y runs between. So for a fixed x in the interval, I start down here and I head up there. So for a fixed x, what's the y? Well, this parabola is governed by the equation x equals y squared. So if I fix the x and I need to determine what the y is that goes with it, I need to solve this equation for y. Doing so, you get plus or minus square root x. So the bottom curve is the negative square root x. The top curve is positive square root x. And so for a fixed x, the y runs from negative square root x to positive square root x. The integrand is the same, 3x to the square root x. But now the integration order is dy dx. So that'll do it then for part B. Part C, we're asked to evaluate the integral in part B. The reason why we're asked to evaluate the integral now is that if we tried to evaluate the integral initially, we'd run into trouble. What's the antiderivative of 3e to the x radical x dx? That's one of those you're not going to be able to find otherwise. So hopefully by changing the order of integration and introducing some unsavory characters in the integrand, we'll be able to knock this thing out. Okay, so here's the double integral with the dy dx order. I'm going to start from the inside out. As far as the y is concerned, this is all just a big constant. So I'm going to get the integral from 0 to 4 of 3e to the x square root x y. And I'm evaluating this from y equals negative square root x to y equals square root x dx. So this is going to be the integral from 0 to 4. When you substitute in square root x and then subtract what you get when you substitute in negative square root x, the square root x's double up. They multiply the 3 to give you 6. Square root x e to the x square root x dx. And it looks like we're going to need a substitution here, so I'm going to rewrite all these radicals with fractional exponents. This is the integral from 0 to 4. 6x to the 1/2 e to the x to the 3/2 power dx. And now I'm all primed and ready for a u substitution. So I'm going to let u be the thing in the exponent, let u be x to the 3/2. So the du is going to be 3/2 x to the 1/2 dx. And I nearly have that. I've got a 6 here. X to the 1/2 dx. So if I want to get a 3/2, I can pull the 6 out, multiply by 2/3. So I'm going to have a 6 times 2/3, the integral. Then I'm going to have my 3/2 x to the 1/2 dx, which is going to give me the du. And then the only thing left inside then will be e to the x to the 3/2. It's going to be e to the u. And since it's a definite integral, we'll change the limits of integration. U is x to the 3/2, so that when x equals 0, u equals 0. And when x equals 4, u equals 8. So the 3 goes into the 6 twice. It gives me a 4. The antiderivative e to the u is e to the u. And this is from u equals 0 to u equals 8. So my grand final answer is going to be 4 times e to the 8th minus e to the 0, which is 1. And that'll do it for quiz 13.